Hi, it's CNT140. We're working on Chapter 4 on UTP. So we had left off talking about terminating outlet jacks, the outlet jack in this part of our structured cabling system, and reminding to follow the color code. As we terminate outlets in the lab room, we'll be looking closer at the color code. And as you look at different outlet jacks, they have different arrangements depending on how the cable is getting terminated into the jack. So you always want to take a minute, orient yourself on A and B color code on that jack and make sure you're using the right code. A trick I'm going to show you is, use a marker Sharpie and cross out the color code you're not using. That way you can focus on the one you need to use. And there is A and B color code on outlet jacks. Same thing is going to apply when you do your modular 8-pin connectors onto a patch cable. There is an AB color code in that as well. We'll be paying attention to that when we terminate our patch cables here in just a week or two. When I look at a patch panel, same thing. They have a and B color code on as well. So you'll want to take a minute and orient yourself on how they have the color code on there, so you're sure to be following the correct color code on their A or B. And again, patch panels mark them differently too, and sometimes they have a little bit different arrangement on how the cables are in there to try to minimize the amount of untwist that you're going to do to terminate. Here's another example here of T568 is marked here, T568B is marked over here. And they're just simply showing you the blue bar and the brown bar over here. The green and orange will flip-flop in the middle depending on whether you're using A or B. No matter what you're terminating, you're remembering to make sure you minimize the untwist. Half inch of untwist is allowed, that's it. Everything should be you should try to keep everything under that half inch limit. When terminating outlet jacks, again, we're going to do that in the lab room, so we'll get a chance to get a little bit more familiar with that in the lab room. But the reminder is keep the untwist minimize as much as possible. And there is different styles of outlet jacks. This was a style we used for quite a while. The cable actually gets fed through here and out through this side of this is like a little plastic sled that goes onto the jack, and then the wires get fanned out, some up this direction and some get actually bent down away from you as you're looking at the screen. So you need to follow the AB color code here. You trim off the excess wires and then slide it onto the jack here and use the termination tool to have this part force the wires into the metal V's over here, the insulation displacement V's, if you will, to terminate that outlet jack. The style we're currently using looks a little more like this. Horizontal cabling gets fed in here, and again, some of the wires get pulled up towards you. Some of the wires get pushed down away from you, depending on the color code. You trim off the excess, slide it into the jack here. The metal V's are back in there, and you use the termination tool again to crimp the two halves together. And when you do, it forces the wires into those insulation displacement connectors. Again, we will do these in the lab room here very shortly, so we'll get a chance to get a little more familiar with it. Same thing when terminating patch cables. It's we'll do that here in a few weeks in our lab room, but with our patch cables, you're using the modular 8-pin connector to terminate onto your stranded unshielded twisted pair cabling. In the basic process, you'll trim some insulation off, just enough to work with, cut off the excess floss here. If there's a divider in the middle, especially if you're dealing with Cat 6, trim that off. Once you do that, fan the color, untwist the wires so that you can fan them out and get them flattened out and in the correct color code order. Once you do that, then you can slide once they're laid out flat, you can trim off the excess and slide it into the connector. And once it's into the connector, then you can crimp. And again, you're needing to watch the A and B color code and making sure the wires get the whole way to the end of the modular 8-pin connector so they will actually get crimped. And we will spend some time doing that in the lab room. We'll make a straight through and a crossover cable to understand the process, but also get some familiarity. As I like to say to people, you're probably not going to be sitting and making patch cables all day long, but there are times you might need to make one for that odd connection. So again, you're using stranded core cable for your patch cables, and there are 3 different types of patch cables that you encounter. There is the straight through patch cable that is used for connecting unlike devices. Switch to router, switch to PC, switch to server, switch to printer, those switch to IP phone, switch to access point. These would all be straight through cables when they are unlike devices. What that the straight through means is pin 1 on this end is connected to pin 1 on this end. So the white orange wire here connects on pin 1 and it connects on pin 1 on the other end as well. And the color code is wired straight through. That is how these devices switches are designed to be. They're designed to accept all these other devices, workstations, printers, servers, phones, access points, security cameras, all those things. They're designed to accept in that pin arrangement. So that would be your straight through cable. There's a time you might need to connect two similar devices, switch to switch, router to router. It's not too common to do PC to PC, but any similar devices that you're connecting directly together, namely switch to switch, router to router kind of thing, will need a crossover cable. And the idea there is, if we look at the pin out, I need to connect the transmit pin on this side to the receive pin on this side. And the transmit here needs to connect to the receive over here. So we need to purposely cross over the orange and green pairs and the blue and brown pairs. That way the sends on one side can get connected to the receives on the other side. That would be a crossover connection. Now, most modern switches and devices, this port actually auto senses that. And if you plug a straight through in and it needs a crossover, it'll sense that and cross it over for you. That's the auto MDIX, the auto crossover, if you will. Most modern devices will do that, but it's still wise to know the correct cord to use in case there is issues. You know, I do actually need a crossover here, and it will work for me in that situation. In the lab room, we tend to follow the whole use straight through between unlike devices and use crossover between like devices. That way we're sure things are functioning correctly. The last type of patch cable we run into is a console or rollover cable. The console cable we use in the lab room to connect to routers and switches for configuration purposes. These guys right here are designed to connect to a serial port in the back of the PC or the serial port here on the adapter that plugs into a USB port on the PC. Okay. The other end is the modulate pin RJ45 end that's designed to plug into the console port on a router, the console port on a switch, the console port on an access point. Excuse me. Those types of things. This console cable, if I were to cut it apart and look at it, it is actually a rollover connection, which means pin 1 on this end connects to pin 8 on this end. Pin 2 on this end gets connected to 7, 3 to 6, and so forth. So literally the entire cable gets rolled over when you connect from end to end. And once upon a time, you actually had to wire these up on your own. You didn't get these cables when you bought a router and switch. You actually had to create your own rollover cable. So that was something we commonly created years ago. We don't commonly create them now, but at least it's wise to be familiar that these console cables I'm using are actually a rollover cable is what they are. So those are the three patch cables that you would run across. Punch downs. There's a couple different punch downs that you might encounter. As I look at closets, I can run into 110, 66, and lesser so, but we should at least be aware, BICs or Chrome blocks. Most of our terminations we're going to deal with are going to be in 110 blocks, either on the back of a patch panel or outlet jack kind of thing. 66 tends to get used for phone cabling, and BICs and Chrome were kind of proprietary designs used by those particular companies. BICs from Northern Telecom, Crone from a Crone company, if you will. So super quickly, here's your 110 block. Old style termination here, you would actually terminate cable on the bottom layer, and then this 110 block would clip on top and you would terminate there. And that would be your connection between two devices, if you will. Well, that 110 block termination style has been adapted to the patch panels that we use. So the punch-in we do on the back of a patch panel is a 110 block. So it's one of those, at least to be aware that that's what we use for our data connections. For phone connections, it was pretty common to use a 66 block. 66 block, I can have one, the phone line from the phone switch, the PBX, the phone line from the phone switch could get terminated on this side, and the actual cable that was going to a phone would get terminated on this side, and you would connect them together using these little bridging clips. So this was a common interconnection block for phone lines and phone equipment, 66 block. BIX block, BIX and Krone were these ones that were proprietary, and they're going to look similar to things you've seen, especially 110 block. Here you terminate one wire on one side of the block, and the other end, maybe the horizontal cable or the cable going to another device, would get terminated on the back side of the block, if you will. Krone block, here was our termination there, similar in style. Just kind of, it'd be worthwhile to recognize that there are different punch down styles. We are mostly going to be encountering this style on the back of a patch panel, 110 on the back of a patch panel. The punch downs usually have this type of color code order, but as we start dealing with patch panels, like I said, you might see the order change a little bit, and sometimes you will see 4 wires on top and 4 on the bottom to try to minimize the amount of untwist in that termination block. So this is typically what you would find, but as we look at patch panels, we're always going to orient ourselves to what we see and follow the color code that's listed there. So patch panels, that's the common block, or the common termination we're going to use. As I look at my cabling infrastructure, the patch panel is here. The horizontal cabling is going to get terminated to the back of the patch panel, the 110 block side. It punches in and stays there. And then we use a patch cable on the front to connect into the appropriate switch port or appropriate switch that we want to make connection to. So here is the back side where we terminate the horizontal cabling. We're punching in a horizontal cable runs into the 110 block on the back, and then the corresponding port on the front, we use a patch cable to go from there into the appropriate switch or switch port. They come in 12, 24, 48 port varieties, pretty much to match up with the switch sizes that you would encounter. Again, here's the back 110 block termination, and then the RJ45 or module 8 pin connector on the front that we would connect to. If we look a little closer at some of the color codes on patch panels, I put a couple in here so you could kind of look a little closer. If I look at this guy, it is actually labeled for the T568B color code. And what I see is, I see the brown wire followed by the white brown wire. I see the green wire followed by the white green, orange followed by white orange, and blue followed by white blue. That is the color code that is printed on this patch panel. So that's one you would follow. If I look at a different patch panel, they actually have both the A and B color code indicated here. So if I were doing the A color code, I would go down the line here, white, blue, blue, white, green, green, white, orange, orange, and white, brown, brown. I would go right down the line just like that. If I were doing the 568B color code, I would follow the one on the bottom line down here, and I would do my white, blue, blue, white, orange, orange, white, green, green, and white, brown, brown. And you notice the only difference between the two is the whites and the greens and the oranges in the middle. Greens is the orange in the middle. The last style like this is going to look like what we have in our lab room. The cable comes in the middle and 2 pairs go to the top and 2 go to the bottom, trying to minimize the amount of untwist in our cable. Well, if I want to use the B color code over here, I'm going to follow this top line here and the bottom line down here. Okay, so I'm going to follow, and they have it marked in here. Here's B, and then down here is B. So I would do white, blue, blue, white, green, green. And down on the bottom, I would do white, orange, orange, white, brown, brown. That would be my B color code. If I wanted to do the A color code, I'm going to follow this line in here and this line in here, the 2 inner lines, if you will. So up top, it would still be white, blue, blue. Then I would have white, orange, orange. You see right there, white, orange, orange. And then the bottom row, white, green, green, white, brown, brown. So again, the greens and the orange flip-flop, the blues and the browns stay the same. That would be the color code I follow there if I were doing A on that patch panel. So whenever you work with a patch panel, orient yourself as to how they're laying it out, color codes that are being used. Okay? When we come back, we'll continue on.